Area of a circle. Before we work on the question set for this lesson, I want to show you this really cool investigation into where that area of a circle formula comes from. So we have a circle here, and you can see the radius, it's marked, right? I'm going to pull this I guess, button, slider, and I'm going to straighten the circumference. All right, so you've seen me straighten the circumference before when we talked about circumference. So there we go. That's my circumference, right? And we have the formula there. The formula for circumference is 2 times pi times r, but we learned that we can also use diameter times pi, right? Because 2 times r is the same as d, right? So we can say d times pi or 2 times the radius times pi. So there's my circumference. Okay, now for the cool part. I'm going to dissect this circle and I'm just going to cut it into 12 equal pieces, right? Kind of like slicing up a pizza or a pie. Then I'm going to drag this little green dot and I'm going to rearrange the pieces. So first, I'm going to lay them all out flat, right? Are we good with that? So right now you can see it dips just a little bit underneath that straight line. I didn't flatten out the curved part. They're still curved. So you can see that it's almost the same length as when I completely flatten it out. It would be a little longer if I completely flatten it out, right? You can see that it just about covers that whole circumference length. Now I'm going to rearrange them so that the red ones and the blue ones kind of fit together, right? Like teeth or like teeth on a zipper, right? So I'm going to keep pulling this and now I fold it in half. Okay. Well, what shape does that look like? Like if you look at the overall shape here, it looks like a shape that we're pretty familiar with. But let me dissect it into more parts so that we can see the shape better. All right, so the parts are getting smaller, right? The parts of the circle are getting teeny, teeny, tiny. And if you come to the live lesson when I do this, we're going to do this together. You'll be able to do it on your own. Ooh, that's a lot of parts. But look what shape we've got. We've got a rectangle. And we know how to find the area of a rectangle, right? So if I want to find the area of the rectangle, I have to do the length times the width. Okay, exactly is the length or the base, right? We did area of a rectangle is base times height. But what exactly is my base and what exactly is my height? Well, let's look at the base first. So this length here, didn't want to write there, but this length here is my base, right? Because the base, whether I measure it on the top part here or I measure it on the bottom part here, it's still my base, right? Look at what that base is, right? So remember, I unfolded it all, right? I had all the pieces lined up and it was about the length of the circumference, a little shorter because it had some rounded parts, right? And then I folded it in half. So if I folded it in half, then that means what I've got right here is half of the circumference. So that means that I would take my circumference, which we can write in this case as 2 pi r, and I'm going to take half of it, right? Because remember, this whole dark black line down here is the circumference. And when I folded the teeth so that they went into each other, then that I folded it in half. So now that length is half the circumference. Well, the 2's cancel out, right? 2 divided by 2 is 1. So I find that the base of my rectangle is pi r. Okay, the height of my rectangle That hasn't moved. That stayed in the same spot the whole time. When I started, it was the radius of my circle. Then I took it apart, it still stayed the radius of my circle. So the height of my rectangle is the radius. So this part, B, is pi times r. And this part, my h, is r. So that's how we get the area of a circle formula. Now, I might have you write this as r pi. But when you see the formula written, the way you're going to see it written most of the time is pi r squared. Now, I've just found that through years of doing these problems with my students, they make less mistakes, or you guys could make less mistakes by doing r pi, because sometimes you forget that r squared is r times r and not r times 2. It's an easy mistake. It happens all the time just by going through something kind of quickly. So I will write the formula like this, but just know that it's the same thing as when you see it written like this. All right, so let's do some problems. We're going to start off very straightforward. Let me get my calculator up. And just finding the area of the circle. So we know that area, let me get my pen. Area is r times r, so radius times itself, times pi. Now, I'm not given r in this picture, right? But I'm given the diameter. So I know that if the diameter, that's all the way across, is 8 feet, then the radius, which is only halfway across, will be half of that. So half of 8, or 8 divided by 2, is 4. So I would do 4 times 3.14. All right, so in my calculator, I'm going to do 16 times 3.14, and I get 50.24, and this is area. So if you remember from our area discussion, that's going to be, we're measuring in squares. Even though it's a circular figure, we're still measuring how many squares would fit inside. That's area. All right, let's try another one. Okay, so now we have area again, diameter again, but this time we're leaving our answer in terms of pi. So if the diameter is 14, remember, like on the last question, diameter is all the way across. The radius is going to be half that. So if the diameter is 14, that means that the radius will be, 7, right? Half of 14 is 7. So I'm going to write my formula again, r times pi. My r is 7, so I get 7 times pi, and that is 49 pi. And in terms of pi means that I leave it like that. And it is in meters, so it's going to be square meters. That means a square that has a measurement of 1 meter by 1 meter, right? Those are the dimensions. All sides are 1 meter long, but it's a square. So that's pretty big, actually. 49 times a little more than 3. And we're talking square meters here. That's pretty big. A square meter, think about how long a meter is. A meter is like, if you remember, like those yardsticks, like those wooden long yardsticks you might have seen in like elementary school, that's almost the same as a meter. So imagine a square that's that big. Every side is that big. A square meter is pretty large. Okay, a circle with a radius, so now this time we're given the radius of 14 feet, is cut into 8 equal pieces. How many square feet are 3 of them? Ooh, all right, so this is a multi-step problem here, right? So let's find the area first. Okay, so the area of the whole pizza, or I guess it's not a pizza. Maybe I'm just hungry. The area of the whole circle is r times pi. right? And we know they tell us the radius is 14. So that's going to be 14 times 14 times, and they say to use 22 over 7. Okay, so let's see, 14 times 14, is that 196? Yes. So we're going to have 196 over 1 times 22 over 7. And I know that because I multiplied 14 times 14 to get 196, I know that 7 goes into that number. So I'm going to do some canceling. I'm going to divide by 7, and I'm going to divide this by 7. And I get 28. So then I have to do 28 times 22, and that gives me 616 square feet for the whole pizza. Now, we're going to cut this into 8 equal pieces, and then I want to know the area for 3 of the pieces. There's 2 ways we could do this. We could divide by 8 to find the area of just 1 piece, right? And then if we want 3 of them, we can just triple it. Another way we could look at it is if we want 3 out of 8 pieces, we want 3/8 of the circle, right? We want 3 out of 8. You'll get the same answer, so let's do it both ways. If I do 616, so 616 divided by 8 is 77. And then that's 1 piece, right? So for 3 pieces, I'll have to do 77 times 3, right? So times 3, and I get 231 square feet, right? So now let's look at it the other way. If I did 616 times 3/8, because that's the fraction of the circle that I want 3 out of 8, guess what? I end up doing the same math because I know that 8 goes into 616, right? So divide by 8, and then 77 times 3 is 231. So I get the same answer. Just do it the way that makes more sense for you. If it makes more sense for you to say, okay, well, it's 8 equal pieces, let me find how much each piece is, and then I'll triple it, then do it that way. The final answer is the same in the end. Okay, so we have apple pies. We're given the diameter, and we have to find, ooh, the cost per square inch. Look at that. All right. So the cost per square inch. Okay, let's do it. So we need to know how many square inches of area we have for this pie, right? So the diameter, it tells us in the problem, the diameter is 8. We don't need the diameter to find the area though, we need the radius. So if the diameter is all the way across and that's 8, then the radius is half of that, which is 4. Right? So let's find the area first. So the area is r times pi, which is 4 times 4 times, it doesn't say what to use, but it does say round to the nearest hundredth. So I'm going to assume decimal. And I think we did that in the very beginning, right? 16 times 3.14, I think it was 50.24. Let me just double check that. 16 times, yeah, 50.24. So that's the square inches. That's the area of the whole apple pie. All right, now, remember back in Module 3 when we found unit price, right? If we want cost per square inch, cost per square inch, it tells us what to do right there. Right there, just setting it up, cost per square inch. means that we have to do cost divided by square inches. So that means that 1105 is going to go on top of my fraction because that's my cost. My area is going to go on the bottom, and then I'm going to divide. 11.05 divided by 50.24. And I get this long decimal, 0.219944, and it's probably rounded here. That 7 probably got rounded. So if I round to the nearest hundredth, remember what that means. That means I look at the tenths, hundredths place, and this is going to be the last number in my answer. But I have to make a decision. Do I leave it alone or does it round up? Well, since the next digit is a 9, it's going to have to round up, right? So my final answer is 0.22. Now, I know that doesn't sound like a regular dollar amount, but it's less than $1, right? It's 22 cents. So the cost per square inch, it's 22 cents per square inch, right? We use the fraction bar or the slash, if we do it sideways, as per. So 22 cents per square inch. It's right there in the directions. If you have to find something per something else, it's always the first one divided by the second one. All right, keep that in mind. Okay, the Singh family ordered a large pizza with a diameter of 20 inches. If one of the members ate 1/8 of the pizza, how many square inches are remaining? Use 3.14 for pi. Okay, so let's do it. Let's find the area. Now again, they give us the diameter. We don't really want the diameter though. We want the radius. So if the diameter is all the way across, and that's 20, then halfway across would be half, which is 10. All right, so now let's find the area. So my area is going to be r times pi, and that's going to be 10 times 10 times 3.14. Well, I can do that in my head because 10 times 10 is 100. And if I multiply by 100, that means I move the decimal point 2 to the right. So that is 314, and this is square inches. All right, so that's the whole pizza. It says that one of the members ate 1/8. How many square inches are left? So listen, we can do this 2 ways. Ready? I'll show you both ways. So the first thing we can do is find 1/8, right? So 1/8 of 314, let's see if that goes in. 314 divided by 8, it's not a repeating decimal, but it doesn't go in without a remainder. Okay, 39.25, that's 1/8 of the pizza. Then we could take that off and see what's left, right? We could do the total amount of pizza, which was 314, and subtract the amount that that one family member ate, which is 39.25, and we would get, let's see, 314, we would get 274.75, right? So that's method number 1. Method number 2 is using fractions. If 1/8 is gone, that means 7/8 are left. So we could do 7/8 times 314, right? So 314 times 7 is 2198. And then on the bottom, we would have 8 times 1. And then let me divide by 8. And I get, thankfully, predictably, I get the same answer. Right? So I could find 1/8 and take it off. Kind of like when we did tax and tip. Remember that in discount? You could find the amount and then take it off, or you could just multiply by the percent that would be left. Same thing, right? I can find 1/8 and take it off, or I can say, okay, let me take off 1/8. That means 7/8 is left. Let me find 7/8. All right, either way, same thing. Oh boy, this one has a lot of words. Okay, so we have a pizza parlor in Tallahassee that sells a pizza with a 16-inch diameter. So if it's okay with you guys, I think you're good on like diameter radius, right? I'm just going to write the radii in right at the top because I know I'm going to need it. So 16-inch diameter means that I would have a radius of 8. A pizza parlor in Jaco, Costa Rica sells a pizza with a 27.8 centimeter diameter. All right, so 27.8 divided by 2 is R equals 13.9. Okay. Ooh, how many square inches of pizza is the pizza from Tallahassee? Okay, so let's start out with the Tallahassee pizza. So we've got area is equal to R times pi, and that would be 8 times 8 times pi, which is, I guess we're using 3.14. Yeah, it doesn't say. So 64 times 3.14 is 200.96. All right, how many square centimeters of pizza is the pizza from Jaco, Costa Rica? Show every step of your work. Okay, so same idea, right? I'm going to have area equals R times pi. So that's going to be 13.9 times 13.9 times 3.14. So 13.9 times 13.9 times 3.14 is, I'm going to round this to the hundredths place. You should do it on your calculator too, so you see what I got before I rounded it. And remember, this is square inches and this is square centimeters. Now, if 1 inch equals 2.54 centimeters, which pizza has the larger area? Now, this is tricky, you guys, because they're telling you the conversion for inches to centimeters. They are not telling you the conversion for square inches to square centimeters, right? It's different. So let's talk about that for a moment. So think about if this is a square inch, right? That means this side is 1 inch and this side is 1 inch. And 1 times 1 gives us an area of 1. All right, so far so good. So now, let me get rid of that. And let me get rid of this. And let me get rid of this. Now, if we're saying that each one of these inches is 2.54 centimeters, that means this is 2.54 centimeters, and this is 2.54 centimeters. What's that area? Well, we have to multiply, right? 2.54 times 2.54, I'm going to round to the hundredths place again, is 6.45. So this conversion factor is very misleading. It's not the one that I need. The conversion factor I need here is that 1 square inch is equal to 6.45 square centimeters. All right, that's tricky. That's why you might remember that I was talking about in the circumference problem, you're better off just always converting first because the conversion factors don't work when it comes to area. So the other option we could have here is to take that 13.9 centimeters and convert it to inches and then find the area again, okay? But we figured out the area conversion factor, so now let's use that. Okay, so we know that the Tallahassee pizza has this area. Oops, let me go get my pen back. Has this area, right? This is the Tallahassee pizza. So we need to know what the Jaco pizza is in square inches. So that's going to be, I'm going to take the measurement that I'm given, put it over 1, and multiply by my conversion factor. Oh, let me write centimeter squared in here. Okay. And then my conversion factor, the centimeter squared part has to be on the bottom because I need them to cancel, right? And this is 1 square inch. So I'm running out of room, so I'm gonna write it down here. So down here, I'm gonna do 606.68 divided by 6.45, which is 94.058, 94.06, let's say. So hold on, let me move this over a little bit. All right, so I get 94.06, right? That is my area in square inches. So this pizza is smaller, right? Now it says, what's the scale factor from the pizza in Tallahassee? I know you can't see this part, but it says to the pizza in Jaco, Costa Rica. So if I'm going from the pizza in Tallahassee to the pizza in Costa Rica, that means I'm starting with the pizza in Tallahassee, which let's just round to the nearest whole number because these are both close enough. So I'm going to say the Tallahassee one is 201, and I'm going to say that the Jaco pizza is 94. So if I'm going from 201 times something equals 94, right? That's what it means when we want the scale factor from one thing to another. It means what do you multiply that first thing by to get the second thing, right? It's getting smaller, but still I'm multiplying. I'm just multiplying by something less than 1. So I'm going to have to divide by 201, and let's see what I get. 94 divided by 201 is approximately, and again I'm rounding, you should do it on your calculator so you can see what you get, 0.47. If I round to the nearest hundredth, that's my scale factor. Now, I could also just leave it as 94 over 201. That is an acceptable scale factor. I don't know if there's any common factors that I could divide by. I know 3 doesn't go in, 2 doesn't go in, 5 doesn't go in, 6 doesn't go in, 4 doesn't go in. So there might be a very large prime number that goes into both of those, but I can't think of a small one off the top of my head. So you could leave your scale factor like this, or you could convert it to a decimal. All right, we ended with a doozy there. If you have any questions, please let me know. I'm happy to answer them, and I will see you soon.